So you know the formula. Whatever
Yeah,
you know, I'm writing over here. Okay.
I know the linear form, the quadratic form, and the cubic form.
A linear
Actually,
form.
linear हमने शायद किया नहीं, but quadratic is ax squared plus bx plus c, and
Good.
cubic is ax cubed plus bx squared plus cx plus d.
Yeah, that keeps going on. Right. Very good.
Yeah. And then what else did we learn? I'm trying to remember. We did vertex form, factorial form, and one more form. But yeah,
Okay,
we did
but in quadratic
that.
equations, you must came up only the questions related to quadratics, right?
Yeah, because actually this test was of quadratics and functions. The
Okay, functions, then functions can be any. It can be linear, quadratic, cubic. Right.
yeah,
Okay.
I think I was talking about functions before.
Oh yeah, you were talking about functions before.
Yeah, but
Okay, so I'll write few things over here. You just let me know if you have covered everything, right? And
okay.
this is the part of your extended quadratic graphs. Will concentrate on quadratics only today. Okay, because that is your major concern. So factorization, completing the square, the formula, graphs, plotting the graphs, finding an equation from the graphs, everything. So you have
Yeah.
done everything?
We've done like the formula. The graphs one, I'm really, really bad at. I'm not very good with that.
You are not aware of the graphs. That's what you're saying?
No, I've done the graphs, but I'm not very good at doing the
You
graphs.
have done the graphs, but you are not very good at it. It's okay. Okay. I'll just write one very simple quadratic equation here. Can you just quickly factorize it, Alicia?
Yeah. I just in my
Very
book.
simple with a plus. Yeah.
X plus 5, x plus 1. No, x plus 5. Yeah, sorry.
No worries. Take your time. It's okay.
X plus 3, x plus 2.
Very good. Right? But if I put a 0 in the front, what will be the answer?
Oh, x equals minus 3 or x equals minus 2.
Good job. Right? So earlier I have written the expression because you factorized it. Now it's an equation, just the basic information I'm giving, and you have solved for the x, -2 and -3. What we
Yeah.
call this as?
X-intercept.
Good. Very good. I was not expecting that answer. Okay, x-intercepts, and we can call it as roots, solutions, anything, right? If I ask you to find the y-intercept from here,
I can do it really quickly. Is it just 6?
6, yeah, right. Good job. Y-intercept is 6. You know 3 points, right?
Yeah.
0, 6, -2, 0, -3, 0.
Yeah.
Right? I'm starting with the graphs because that is your weak area right now. So can we plot these 3 points here on the quadratic, on the coordinate geometry? See, you
Yes.
found all the points. I didn't help you at all. Just plot all of the points.
I have to draw the graph.
No, just draw a little like with the idea. I don't want the exactly correct graph. You just draw like I am drawing here, right? 1, 2, 3, -1, -2.
It's
And
facing upwards. It's like, how do I show you?
yeah, okay. I'll stop sharing, then it goes away. But let me draw first, and if it looks like this is 1 point. 6, 0, right?
Yeah.
6, 0, -2, 0, 3, 0. And you said it is facing
It's
upwards.
-3, 0.
Oh, sorry, it's -3, 0. I did opposite. Both are -3. -2, -3. So these 2 points and this. Do you know how the quadratic graphs actually looks like?
Yeah, it's like a parabola.
Parabola. Good. Parabola, U shape, right?
Yeah.
So today we are going to concentrate on vertical parabolas. When we have an equation with my square on x, right? Y equals to x square. We are going to concentrate on that. If my leading coefficient, what do you mean by leading coefficient, Alicia?
The coefficient in front of the x squared.
Yes, very good. If my leading coefficient is greater than 1, my parabola is always open upwards. Always. Yeah. And if it is upwards, what does this symmetry point will give us?
Meaning?
If my parabola is upwards, is this symmetry point? This is a symmetry point. Why we call it as a symmetry point? Because here, if I draw an axis, it is reflection for each other, right?
Yeah.
This point will be my minima. We have a word for this. You may have heard.
Minimum. Yes, we did this. We did this in class.
Yes. It is always connected. It's just like how we take it, right?
Yeah.
It is called minima. So whenever my A is greater than 1, that means it is positive. My symmetry point is minima. Correct? And if it is less than 1, obviously the other way around, it will be open downwards. It will gives me
maximum.
Maxima, right? So I'm drawing two graphs here, one with the minima, one with the maxima. This is my minima. And how to get a minima, I'll tell you the direct formula. Maxima. Sorry. Maxima, right? First, we'll try to understand the terminology. Here A is greater than 1, here A is less than 1, and my equation is ax square plus bx plus c. General equation I'm taking. Okay. Now, when I ask the domain and range of minima or maxima, can you just let me know what does domain and range is here?
Domain is the, it's the something of the x function like that, and
Very
range
good.
is like that. But I have
Correct. Very good. Yeah, you're right. You're right. Domain means all the x values which is satisfying my given function.
Yes, that's the one.
Yes. You said whatever you said, I understood that you are explaining that. And range is all your y values which is satisfying by that particular function. We are talking about the particular function, not of the general thing, because domain and range is of a particular function. Okay, so it is all x. So look at both of the graphs, right? You can see, and this is an arrow. Arrow means it's keep going. It never stops. What do you think the domain is?
For which one?
Both.
Oh, it's greater than like 1.
No, that is the leading coefficient, Alicia.
Yeah.
Domain. Okay, whenever you have to see the domain, you just concentrate on your x values, where my graph is going on x values. So you can see if I keep on extend it, it keeps on increasing, right? It is never going to stop. How long it is going to go? Because arrow means never going to stop. So domain means all the values. It is covering all the values. X belongs to R. X belongs to all real values. All real numbers.
I always forget about that.
That means your rational, irrational, in everything, right? X belongs to R. So domain for your quadratic graphs will be always this. No matter whatever the graph it is having. It is a vertical parabola or is it a horizontal parabola? Doesn't matter. I don't think so you are having right now this view will gonna go later just for the information. Okay. So domain will be all real values for your quadratic functions. You don't have to think before writing it. But range is not all real values. Why I said this?